This is lesson 2.5, Evaluate Algebraic Expressions. It is found on pages 89 through 92 in your workbooks. So does anyone know the loudest pet you can get? What is the loudest pet that you can get? Anyone know that? A trumpet. A trumpet. 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 Okay, we're just going to move along now. Alright, our learning target for this lesson is going to be to evaluate algebraic expressions given values of their variables. Alright, and so hopefully again you will be at a 3 by the end. You know, if you don't understand it yet, well, that's okay. That's why we're going to do this lesson. Alrighty. In our look back, we're going to evaluate each expression. So 2 times 2 is 4. 6 minus 4 is 2. 7 times 0 is 0. So 14 plus 0 is 14. 20 divided by 2 is 10. And 10 minus 4 is 6. 12 minus 3 is 9. Remember, we do parentheses first. And 9 times 4 is 36. Now we're going to look forward, evaluate each expression when p equals 1, and we're going to understand that each one, we're going to replace with 1. So this is going to be 1 plus 1, that's going to be 2. That's going to be 1 times 2, that's going to be 2. This is going to be 5 minus 1, that's going to be 4. This is going to be 4 divided by 1, that's going to be 4. So what we do with the expression when we have a variable here, that's what that letter is called. A variable is just a letter or a symbol that represents a number. And in this case, the number is 1. So in each of these, you replace that variable with 1. Alright, how would you evaluate the expression 4 plus x divided by y when x equals 12 and y equals 2? So we're going to put 12 with x and 2 with y. So 4 plus 12 divided by 2. See, we've replaced x with 12 and y with 2. Well, order of operations tells us division comes first. And that's how you would do it. Our key concept for this lesson, we're going to evaluate algebraic expressions. An algebraic expression is an expression that contains numbers, operations, and variables. To evaluate an algebraic expression, substitute a number for each variable. So, evaluate n plus 10 when n equals 23. So we're going to replace n with 23. So n plus 10 equals 23 plus 10, that equals 33. So we substitute 23 for n, we add 23 and 10. So n plus 10 when n equals 23 is 33. Now look, n's not always going to equal 23. Please understand that. It's just in this one, the variable is n and it can vary. It can change. It can change its value. That's why it's called a variable. And in this part, it's 23. How do we know it's 23? We're just given that value. When you're given the value, you just replace the variable with the value. Alright? Another example. Evaluate 17 minus y times 5 when y equals 3. So substitute 3 for y. Did that. We do our order of operations. 3 times 5 is 15. 17 minus 15 is 2. So 17 minus y times 5 when y equals 3 is 2. Alright, let's do some in-class practice. I'm going to solve number 1 with you, and I want you to solve number 2 by yourself. Alright, so evaluate 25 plus b when b is 46. So 25 plus 46. We got 11 and 7, so 71. Alright, you solve number 2 and then we'll go over it. Alright, so we're going to replace c with 54. 14 minus 8 is 6. 4 minus 2 is 2, so 26. I'll solve number 3 with you, and you can solve number 4 on your own. So we evaluate 4 times h when h equals 15. So 4 times 15, that is going to be 60. All right? You solve number 4, and then we'll go over it. All right? E equals 72, so 72 divided by 8 is 9. All right, moving along. All right, I'm going to solve number 5, and you can solve number 6. So evaluate z plus 12 times 2 when z equals 6. So 6 plus 12 times 2, 6 plus 24, that's going to equal 30. All right, you solve number 6, and then we'll go over it. All right, so we evaluate 36 minus 30 divided by q, and q is 3. So 30 divided by 3 is 10. 36 minus 10 is 26. All right, you go ahead and solve 7, 8, and 9. Solve 7, 8, and 9, and then we'll go over it. Now, you're evaluating each expression with m equals 12. So in each of these, what are you going to replace m with? 12. All right, go ahead and solve those, and then we'll go over it. All right, so 41 minus 12 is going to be 29. 96 divided by 12 is going to be 8. And then 12 plus 28 is going to be 40. Right? We're replacing m with 12 each time. All right? These next three are a little more complicated because they have more than one expression, but you're doing the same thing, except in this one, d is going to be 5. So you're replacing d with 5 in each one. All right? Go ahead and do those three, and then we'll go over it. All right, so 37 minus 2 times 5. 37 minus 10 is 27. 6 times 5 divided by 10. 30 divided by 10 is going to be 3. 79 plus 5 divided by 22 minus 15 is going to be 84 divided by 22 minus 15 is going to be 84 divided by 7 is going to be 12. Alrighty, in these next ones, you're going to have it where you have two variables, but it's the same concept. You're replacing those variables with the numbers it gives you. So I'm going to solve 13 and 14 with you, then I want you to solve 15 and 16 on your own. So we replace f with 2 and g with 3. 2 times 3 is 6. 6 plus 17 is 23. And then, again, g with 3. See, g is 3, f is 2. So 5 plus 18. Oh, I need to take those parentheses off. 18 divided by 2. 14. You solve 15 and 16, and then we'll go over it. Alright, so 18 minus 2 times 3. 18 minus 6 is 12. Alright, so 6 times 3 divided by 2 plus 2. So 6 times 3 is 18. 18 divided by 2 is 9. And 9 plus 2 is 11. Alright, Number 17 is structure. Evaluate 8 plus star times 7 when star equals 4. Right? So our variable here is going to be a star. So our variable, instead of a letter, is going to be a symbol, and our symbol is star. So the same thing, we're going to replace the star with 4. And when we do order of operations, we do multiplication first. And 8 plus 28 is 36. Alrighty, let's look at some number sense. Would the value of the expression be greater when w equals 3 or when w equals 6? Explain how you know without evaluating any expression. Well, it would be, w would be 3 dividing by 3 or dividing by 6. Which one would be greater? Well, the 3, right? And here's why. Smaller divisors produce larger quotients, right? Just to prove it, let's show it. So we've got 48 divided by 3, 48 divided by 6. 48 divided by 3 is 16. 48 divided by 6 is, what is it, 12? 12? No, 13. No, it's not, silly, it's 8. 8. 48 divided by 6 is 8. Alright, number 19 is open-ended. Write an algebraic expression, give the value of the variable, then evaluate the expression. Here's what I want you to do with this. I want everyone to do this, and then if we're in class, congratulations, I'm going to go around. If you've done it correctly, you get a Jolly Rancher, right? Of course, at home, maybe you can do it and then tell your parents, hey, you should give me a Jolly Rancher for doing this. Alright, go ahead and do that. And then I'm going to do one of mine, and then we'll move on. Alright, so here's my expression. Haha, I did a stinking easy one, didn't I? J plus 1 when j equals 1, so 1 plus 1 is 2. You could have done something that easy. Hopefully you did something easy for yourself. Alright, moving along. Alright, so we're going to complete the input-output table. Our input for x is going to be different each time. Here it's 0, there it's 1, there it's 2, there's 3. But we're going to replace x with each of those and have our output. Here's what I mean. So x here equals 0. So we've got 0 plus 8. That's going to be 8. This one is going to be 8. We've got 1 plus 8. X is 1. That's going to equal 9. We've got 2 plus 8. That's going to equal 10. 2 plus 8 equals 10. And then 3 plus 8 equals 11. Alright? You go ahead and complete this table, number 21, and then we'll go over it. Alright, here we've got 12 minus 3, that's going to be 9. Here we've got 12 minus 5, that's going to be 7. Here we've got 12 minus 7, that's going to be 5. And here we've got 12 minus 10. Sorry, that was kind of messy. 12 minus 10, that's going to equal 2. Alright, so same thing for number 22. You're going to input x each time. Each time x is going to be a different number. Go ahead and do that, and then we'll go over it. Alright, so 0 divided by 2 is going to be 0. 2 divided by 2 is going to be 1. 4 divided by 2 is going to be 2. And then 6 divided by 2 is going to be 3. Alright, let's connect to real life. On our example, the expression 25 plus 8 times m gives the cost in dollars of a video streaming service for m months. What is the cost of this service for 6 months? 1 year. Right? And they've got this input-output table for us. And you know, I already think that the only thing we need is this, right? When m equals 6, and then we need for it to be 1 year. So we put the input in at 6. So m is going to equal 6. M is the number of months. So 25 plus 8 times 6 equals 73. So the service costs $73 for 6 months. Well, there are 12 months in 1 year, so you double your answer. find the cost for 1 year. There it is. So the service costs $146 for 12 months or 1 year. All right, something like that in mind. The expression 30 plus 6 times M gives the cost in dollars of a different video streaming service for M months. How much would you save after 6 months after using this service instead? All right, so you're going to need this information here, right? So we know that it costs $73 there. We need to find out the service for 6 months here. 30 plus 6 times 6. All right, go ahead and find that. Subtract it from the $73 to see how much you would save. Go ahead and do that and we'll go over it. All right, so 30 plus 36 is 66. 73 minus 66 is $7. You would save $7 by using this service instead. Right? Hope you saw that. Hope you just didn't answer 66. You had to take that 66 and subtract it from the 73 to find out how much you would save. All right. On this last one, I want you to read it and then solve it. Go ahead and do that and we'll go over it. All right. Write an algebraic expression that gives the total cost in dollars of a soccer team's jerseys, where P is the number of players. What is the cost of jerseys for a team with 9 players? So our expression would be 15 times P. Well, P equals 9. So we would do 15 times 9. 9 times 5 is 45. 9 times 1 is 9 plus 4 is 13. So $135. All right, let's look at our learning target and I can statements. Evaluate algebraic expressions given values of their variables. So hopefully you can do that. Hopefully you know that you put in the number when it gives you the value of the variable. I can substitute a number. There we go. I can substitute a number for a variable in an algebraic expression. I can evaluate an algebraic expression with one operation. I can evaluate an algebraic expression with more than one operation. Hopefully you can do all this. And you know what? If you can't, that's okay. Still love you. We can practice together. All right. Y'all have a good one.